Welcome back to your channel QERT, where we resolve all the issues regarding data engineering. And I'm your host Ganesh. So let's start today's video. Today's video is about optimization. So we are going to discuss different file format. This is a continuous video, episode 3 of optimization, where I want to explain you 25 to 30 ways to do the optimization in Spark or PySpark. Let's start the video. So why file format does matter? We have to understand this part first at the beginning itself. So impact on storage size. So suppose you are using a small file, suppose within 1 MB, and that can hold a very large data instead of a very large file like 1 GB or more than that, maybe 5 GB, maybe 10 GB, and that is having the same data which can be stored in that 1 MB file. So think according to it, which will be the better, which file format will be the better in this case, the one which can store a large amount of data in a small storage space, or the one which has large data but it's also take a very huge space in storage. Reading speed. So suppose, think again the size of the file. I mean, which file you can read faster using Spark, the one which has used a small storage space, I mean which has very small size but can keep the same amount of data which being used to keep the same amount data using the large file, and Spark job performance. So if the reading speed improve, then the job performance of course gonna improve. That's the basic idea here. So right format can make your job 3 to 5 times faster. So how can that be possible? Suppose you are trying to read a file which is taking 10 minutes only to reading the file. However, instead of that, if you can use the same data in a small storage file, format file, that is more easier to read. While suppose uh, read is the action which you are going to perform. So suppose you are reading a file that is taking only 10 seconds to read 1 million records of file. So of course you are going to use that type of file, but there is some uh, things you have to consider, and according to that you will choose the file format. Of course, effect cost efficiency in the cloud. So of course, small storage means small cost, large storage means large cost. If your file reading time is more, that means you are utilizing more resources, that means more cost. If your file size is small, that's mean uh, less resources, less cost, because it will take less time compared to that. I mean, let's discuss all of this in details. So let's discuss about the file format supported in Spark. What kinds of file format we can use in Spark while working with Spark. So text formats are available like CSV, TXT, then there is XML format, XML, then tab separated file you can utilize. So there is those type of file formats available for text. Columnar, if you are reading the using the columnar file format like Parquet and QERT, then you can utilize the row-based file format like Avro, sequence files. Then, of course, last but not the least, we have table formats, which is Delta Lake and Iceberg. So Those are the file formats we can utilize while working with Spark or PySpark. Moving forward, so I am here trying to rank the file formats by optimization, because our main goal here is to discuss the optimization, how we can optimize the job, the application, the Spark application itself. So Delta Lake on Parquet file, if we are creating a delta lake, that is a table format, that is one of the best and optimized file format. We can say it has acid transition, compaction, schema evolution, everything we can do on that file itself if we are utilizing the delta lake. Apache Iceberg, the same. We can utilize the hidden partitioning, advanced metadata. So yeah, that's how it can help us. Apache Hudi. Okay, then we have Parquet, Columnar, Predicate Pushdown, Compression. Those are the available in Parquet. QRC, again the columnar format, strong compression, hype oriented. Avro is the robust, great for streaming. JSON file format, as you know, it's a semi-structure file format, parsing overhead. So simple file format which will get is CSV, but there will be unable to do the push down, predicate push down, or partition pruning, and it is also IO heavy. That's mean it will take time to read and write the file. So other file format versus columnar file format. In my experience of 9 years, I have learned that the columnar file format is basically common to use and best optimized version of the file formats available in Spark. I mean, other also we can utilize based on the use cases, but most of the case, if it's possible, you are going to utilize the columnar file format like Parquet. So if you are utilizing other file format like CSV, JSON, Avro, sequence file, that is row based, large size. So I, at the starting of the video, I was saying that there's different of file size, even they have the same amount of data. Suppose 1 million data in both the file. Let's take example of CSV and Parquet. So in CSV, 1 million data, that will come around maybe 1 GB. Okay, and same file format in same file record size in Parquet may have uh, 5 MB. So 5 MB, 10 MB, you can see the difference where 1 GB and where 10 MB. Okay, so this is just a basic guess, but different will be like that itself. So when you will utilize, suppose CSV row based file format, large in size, so file, if the file is large, then slower scan we can expect, and we'll expect no predicate push down. I mean, it does mean that if particular data, if you want from a file, okay, you cannot do that while reading utilizing Park. If you are using CSV, you have to read the whole file, then you can filter the data or any particular column if you want, but while reading you cannot do that. But if you are using Parquet, the column based file format, that has small size and faster query, it is quite understandable. But here you can utilize the predicate push down and partition pruning also. So while you want to do the filter while reading itself, suppose you want to choose a particular column, suppose name column and salary column, you only want to read those particular column. So this is a column based file format. You can easily select that column from the file itself while reading itself. You don't have to read entire file, then filter out that two particular columns out of that. And then you also can filter out the data. Suppose from data itself you want to pull data for a particular period. Suppose you have the sales data for starting from 2000 to 2025. You want to check only the 2020 data, so you can just use the filter condition there while reading it, and only pull the 2020 data available in that particular file. So that way it will be more optimized to use. Let's discuss further optimization with Columnar. What will happen if, what you will get if you do work with columnar file format like Parquet. So partitioning by high selectivity columns is event date. Suppose if one, as I gave you example, if you want to filter particular based on particular event date or date range, suppose 2019 to 2020, all the data you want to pull, you can do that very easily. Compression, if you are utilizing the columnar file format like ORC and Parquet, you can utilize the compression there also. Especially in Parquet you can utilize the snappy, that is very fast. Column pruning, so as I have mentioned, select only require column. So suppose there is a hundred of columns available in your data, okay, and you want to pull only the ID, employee ID, and the sale they have made, the amount of sale they have made, okay. You only two columns you want to pull, you can do easily that using, if you are utilizing the columnar file format, that is Parquet or ORC. But if you are using, suppose, other file format or a row based file format, like suppose you are utilizing CSV, then you have to read all the file, I mean all the data in the file. Suppose there's a 1 GB or 10 GB of data available, you have to read all the data, then from there you have to select those two particular column. So I hope I am able to explain you why it is a good idea to use the columnar file format whenever possible, but every time it will not be possible. Again, suppose you have small data, you want to read the whole data, and uh, converting that data into Parquet can be challenging. You have the CSV, that file, that time you can go ahead and read the data and do your work, do your stuff. Every time you don't have to convert the file format and read it. If you have already available the CSV file, just go ahead and read it, okay, do your stuff. But if it's possible for you, if you are writing to write the file in Parquet, while writing it, write the file in Parquet, that will be optimized. Okay, to do this I will utilize the Databricks. You guys may think sometime why I always utilize the Databricks. So the actual thing is, the reason utilizing Databricks, it is very user friendly while learning. I mean, basically, I honestly speaking, I have learned Spark using Databricks itself, and now we have the free edition of Databricks. Previously, we were using the community edition. In free edition, we can utilize a lot of things. It is totally free. Instead of community edition, you can move to free edition now, and it will be very much helpful to you. Okay, so now I'll show you the data where I have the data. So here I have saved FF file format demo sample. So here in this location I have saved that particular file with 1 million record, 10 lakhs record. uh, I have saved in two files. One I have named CSV P8, and P8 is partition. I have, while writing, I have partition it, 8 partition. And Parquet, the same file I have saved in Parquet format, which I have named Parquet P8. So here you can see the files are available here. Okay, 8 partition, you can see this is the CSV file, and another file which I have, that is the Parquet file, that also you can see here. The again the partition, 8 partition. Here you can see the difference, same file, same size. Okay, here if I calculate this same number of records available, if I try to calculate what will be the number here, around 8 into 2 is 16 MB, 17 MB only. Okay, but let's try here the CSV file, how much uh, memory it is consuming. So 6 into 8, 48. So it is almost 48 MB. So same amount of data Parquet file is consuming 8 17 MB space, and CSV file is consuming 48 to 50 MB around. So you can see the difference here. This is a small amount of data, only 1 million, but guess while you will utilize the very large amount of data, like suppose 50 GB, 100 GB, or more than that. Think about that, what will be the file size in CSV and the Parquet. So yeah, so this is the file I am trying to read here, the file. So to save the time, I have already read it here from the location. I am reading here CSV P8, okay, and also reading Parquet P8. Let's see the difference in time. So here you can see this took around 8 minutes of my time to read the CSV file which is available. But let's consider the Parquet file which I have read. It took, this is simple reading, okay, reading operation, read operation. I have not write it, or I have not done anything else. It took only 3 seconds. So you can understand the difference between these two type of file formats. Not this two only. The I'm trying to compare these two, but think this way: the columnar format versus others. And yeah, here it took the Parquet file reading, it took 3 seconds only. Okay, just a simple reading. Okay, here you can see we have read 1 million records. Here also we have 1 million records. Okay, okay, now in front of you, what I'll do is I'll read again. So yeah, I have started my serverless compute warehouse to perform the task. I have to do that here. I have to connect it. It is totally free, guys. If you are learning it in Databricks, you can go ahead and easily do that. So here we'll see the example. Read the projection, only 2 columns. So what we are trying to do, we are trying to read 2 columns, okay, from the data. So projection column is country, okay, and event type. These 2 columns particularly I want to read from our data. Okay, I'll do it 2 times, one with CSV and another with Columnar. Okay, so what code I have wrote here, you can check to read. So here Spark read options I have provided here is header is true. CSV, I have provided the CSV path, or maybe I can provide here the CSV path. So I'll take the path from here, the same file we want to read. Then we are providing select projection columns, that is these two, and then we are calling the action. We know the importance of taking the action after transformation. So yeah, we are doing it here, and same we are doing for the Parquet also. So in Parquet, we'll read the file and you select the projection column. So I'll explain later. After reading, I'll explain why the time took long for the columnar format. I'm sorry. Okay, so here we'll try to run, and from the CSV file and from the Parquet file where we have the same data, we are trying to pull same 2 columns, and we'll check the timing, how long it will take. So let me explain how it will happen. So in case of CSV, what it will do, it will read the whole data, It will take the whole data in the RAM and read the whole file and create the df. Okay, and in case of Parquet, what it will do is basically it will read the particular two columns directly, not the whole data. So you can understand why Parquet will be the faster. Parquet is the faster way to do the work. Yeah, so it is completed now, and now we can see the timing here. It took uh, CSV file to read the CSV file and do the filter of two column. It took around 4 to 9.52 seconds. Okay, where reading the Parquet file and doing the filter it took only 3 seconds. The reason also behind this is it first read the whole file, then it did the filter. Okay, but in case of Parquet, it directly pull the particular two columns which we are trying to read. Okay, that's it for this video and the demonstration. I hope I was able to make you understand. I mean, what are the things we should do, what type of file format, where when we need to use that for simple cases, for small files, and already if your file is available in CSV on those cases, you can consider the CSV file. While reading the file, you don't have to always just transform that to Parquet file and use that. But while writing that file, please write that in Parquet so that next time while you are going to use that file, you can utilize that optimization also. Okay, so what are the takeaway of this demo? Columnar Parquet was you win on projection and filtering because of the column pruning and predicate pushdown. Storage is typically smaller with columnar compression. Delta, Iceberg, and Hudi add operational superpower on top of the columnar file format. Practical rule: land raw. So when you will get the file that maybe will be CSV format, JSON format, or Avro raw based format. Okay, your raw file you can curate to Parquet or Delta. I mean, you can transform that after doing the transformation you need to do on that file or cleaning. You can do then save that or write that file in the Parquet file. Okay, partition, use the partitioning. You can check out my video on partitioning. Do that sensibly. Avoid small file creation that will create while writing. That will create challenge for you again. So those are the things you need to keep in your mind. Thank you. If you have any question, please post that in the comment section. My name is Ganesh Ghosh, the lead data engineer and AI enthusiast. Bye bye for the day. Thank you.